talking about 2's complement, okay? So it says over here, up until now, we have assumed all binary numbers are positive numbers. Okay, so right now, what we have learned, all the binary numbers that we have dealt with up to this point have all been positive binary numbers, okay? So to allow the possibility of representing negative integers, okay, we will be learning something called 2's complement. So once you learn 2's complement, you will now be able to represent negative decimal numbers as well in binary format, okay? Up until now, we have been only representing positive decimal numbers in binary, okay? But once you learn 2's complement, you will also be able to represent negative numbers, negative decimal numbers in binary format, okay? Right, let's see how it works, okay? So over here, we have our position value table. As you can see over here, we have the position value table, okay? But there is one change that we make in a 2's complement position value table, okay? So in this table over here, since we are now dealing with the topic of 2's complement, we make only one minor change, which is the last 2 to the power of 7, the position value is minus, okay? It becomes minus 128. Everything else remains as it is. It is only the 8th bit, okay, that becomes minus 128, okay? Right. So over here, they have just explained everything over here, okay? Let us directly go into an example, okay? So over here, the explanation has been given, okay? Let's directly go into an example. Let's take the number 19, okay? We are taking the number 19 and we are converting the number 19 into 2's complement, okay? This is a positive number. So I'm going to show you how we write a positive number in 2's complement. It is the same thing as the normal way we have been learning, okay? So if you take the number 19, you can see we have put the positions. Okay, let me show you in case you have forgotten how did we get 19 into this format. In case you have, let me just show you how we got over there. Okay, so if we had to take the value 19, okay, let's take the number 19. Okay, so we have the number 19, okay, and we want to convert this into binary, okay, and we want it to be in 2's complement, okay? I mean, there's no need for me to write 2's complement even, but since we're on the topic, I'm just writing it because it's going to be the same value. Okay, it doesn't matter. So if we are to put the position value table, we would start with 2 to the power of 0, okay, which is equal to 1. Then we have 2 to the power of 1, which is equal to 2. Then we have 2 to the power of 2, which is equal to 4. Then we have 2 to the power of 3, which is equal to 8. Then we have 2 to the power of 4, which is equal to 16. Then we have 2 to the power of 5, which is equal to 32. Then 2 to the power of 6, which is equal to 64. And then 2 to the power of 7. By the way, do remember this is minus 2 to the power of 7. So it's going to be minus 128 because we are dealing with 2's complement. Okay. So now if we are to take this value 19 and convert it into binary format, I'm going to be using the subtraction method. Okay, there are two ways to convert. Now I taught you, you can use a subtraction method or you can use a division method. Okay, I'm going to be using the subtraction method. Okay, so when you take 19, when you take the value 19, 19 is closest to which position value? And remember, when you select a value, when you select a position value, it should either be equal to this value or it should be less than it. Okay, you cannot take a value that is greater than the value you're looking for, or I mean greater than the value that you are trying to convert. Okay, so if you look over here, 19 is closest to 16. Okay, 19 is closest to 16, so we put a 1 at 16. Okay, so 19 minus 16 is equal to 3. Okay, so we have a remainder of 3. Okay, we have 3 remaining. So 3 is closest to which position value? You would say it is equal to, it is closest to 2. So we put a 1 over here. So now 3 minus 2 is equal to 1. So 1 is closest to 1. Okay, that's what we do. And then we fill the rest with zeros. We fill the rest with zeros. Okay. So this is how 19 is converted. This is how 19 is converted into binary in 2's complement format. Okay, this is how you convert 19. Okay, let's take another example. Let's take an example such as we are taking the number minus 67. Okay, we are taking the number minus 67. So now I'm giving you a negative decimal value and I'm telling you to convert it into binary. So as soon as I give you a negative decimal number and say convert it to binary, immediately you should tell me, okay, we must use 2's complement. Otherwise, we will not be able to represent this number in binary. Okay, right. So step number one, what we do is we write minus 67 as 67 in binary format. That is step number 1. Okay, there are altogether 3 steps. Step number 1 is take minus 67 and write it in binary as positive 67. That's what you do first step. Okay, so let's do that. So I'm gonna take minus 67. Okay. Okay, so step number 1, convert it as 67. Okay, so step number 1, convert it as 67. Okay, so let's draw the position value table. So I'm not going to be writing 2 to the power of 1, 2 to the power of 2. I'm simply going to write the position value directly. Okay, so 2 to the power of 1 is, 2 to the power of 0 is equal to 1. So I'm going to start with 1. So you have 1, then you have 2, then you have 4, then you have 8, then you have 16, then you have 32, then you have 64, then you have minus 128. We are in 2's complement. Okay, minus 128. Okay, so now how would you write 67? How would you convert 67 into binary using this subtraction method? Okay, so what we do is we take 67, and 67 is closest to which value? It is closest to 64. So we put a 1 at 64. Okay, so 67 minus 64, we have a remainder of 3. 3 is closest to which position value? It is 2. So we put a 1 over here. So now we have 3 minus 2, which is equal to 1. Okay, so we put 1 over here. 1 is closest to 1, so we put 1 over here. Now we fill the empty gaps with zeros. Okay, the empty gaps, we fill it with zeros. Okay, this is the basics of converting a decimal number into binary. Okay, so this is step number 1. Now, if you look at your tutor, in step number 2, it says swap the ones and zeros. So step number 2 is swap the 2. Okay, so wherever you find 1, make it a 0. Wherever you find a 0, make it a 1. This is step number 2 in 2's complement. Okay, so step number 2, let's do it. So in step number 2, okay, so step number 2 is we swap. Okay, swap. Okay, so this answer, we need to swap it. Okay, so let me write that answer now. It would be 1 0 1 1 1 1 0 0. Okay, that's exactly what I have done. So 1 0 1 1 1 1 0 0. Okay, I have done the swapping. That's step number 2. Step number 3. Step number 3 is then goes on to say add 1 to the number. Okay, the number that you just swapped, add 1 to it. Okay, so let's do that as well. Let's do that as well. Okay, so I'm gonna simply do step number 4. Sorry, step number 3, which is add 1. Okay, so I'm going to add 1 over here. Okay, let's see how much it comes to. So 0 plus 1 is 1, then 0 1 1 1 1 0 1. Okay, so this is the result that we do get after adding 1 to it. Okay, step number 4, is there a step number 4? Multiply the values by their position values and add them together to get the final value. Okay, so now it's time for us to do the conversion. Okay, so before we do the conversion, let me write this value with the position values on top, so it will be easier for you to multiply. Okay, so step number 4 is multiply values by position value. Okay, so if you take this, so we have 1 2 4 8 16 32 64, and then remember here we have minus 128. Okay, so over here we write our values. Let's put a line over here. So this value I'm writing it over here. So we have 1 0 1 1 1 1 0 1. Okay, so now we have to multiply the 2, okay, value by the position value. Okay, so initially we have 1 times minus 128. Okay, so we have 1 times, sorry, we have 1 times minus 128, which is minus 128. So minus 128 plus 32 plus 16 plus 8 plus 4 plus 1. Okay, so when you take minus 128, you start from minus 128. As you keep adding these values, you would get minus 67. Is it clear? Okay, so this is how we represent a negative decimal number in binary. Okay, so multiple steps to do. We'll do a few more examples so that you'll be able to grasp it better. Okay, so what I want you to do now is you need to add this. So you start from minus 128 from the bottom, minus 128, you add 32 to it. Then you add 16 to it. Then you add 8 to it. Then you add 4 to it. Then you add 1 to it. You would get minus 67. Okay, so this is how you write a negative decimal value in binary format. Okay, you have to use the 2's complement. Okay, if you're confused, let's take another example. Let's take another example from over here. Okay, so the example that we have is, let's take the number minus 18. Okay, let's take the number minus 18. So if we are to come back to our note, okay, let's take minus 18. Okay, now since this is a negative decimal number and we want to convert into binary, we have to use 2's complement, because only in 2's complement you can represent a negative value. Okay, so what we do is step number 1. Okay, so then step number 1 is write it in binary as 18. Okay, so initially we take it as positive 18. Initially we convert it as positive 18. Okay, that's what we do first step. Okay, so if you put the position value table, we have 1, then we have 2, then we have 4, then we have 8, then we have 16, 32, 64. And remember, we are dealing in 2's complement, so you can't put 128. You have to put minus 128. Okay, because we are dealing in 2's complement. Okay, so if we are to take 18, 18 is closest to 16. 18 is closest to 16. So 18 minus 16 is equal to 2. Okay, 2 is closest to 2. So we put 1 over here. 2 minus 2 is equal to 0. So that's it. Okay, so we fill these spaces with zeros. Okay, we fill these spaces with zeros. Okay, so this is the answer that we have got. Okay, step number 2. Step 2, swap. Okay, step number 2 is we swap. The zeros become ones and the ones become zeros. Okay, so what we get now is 1, 1, 1, 0, 1, 1, 0, 1. Okay, so after swapping, this is what we get. Okay, step number 3. Step number 3 is add 1. Okay, I hope you remember. I think I should take this a little that side. Okay, step number 3 is we add 1. Okay, so let's put 1 over here and we're going to add it. Okay, I hope you remember these steps. So 1 plus 1 is equal to 2. Okay, in binary, 2 is equal to 1, 0. Okay, in binary, the decimal number 2 is written as 1, 0. So we put 0 over here. We put 0 over here, and the 1 is carried forward here. So here we have 1, 1, 1, 0, 1, 1, 1. Okay, so then step number 4. Step number 4, multiply value by position value. Okay, so if you put the position value table over here, we have 1, 2, 4, 8, 16, 32, 64. And remember, we are in 2's complement, so we have minus 128. Okay, and if we are to bring this value over here, okay, what we have is 1, 1, 1, 0, 1, 1, 1, 0. Okay, so now you have minus 128 plus 64 plus 32 plus 8 plus 4 plus 2. And if you were to add them all up from minus 128, if you were to keep adding these values, you would reach minus 18. Okay, so this is how you write a negative decimal number in binary format. Okay, let's take one more example. Let's take one more example. Let's take the value minus 127. Okay, let's take the final one, which is minus 127. Okay, so if we are to take minus 127, okay, we want to write this in binary format, so we have to use 2's complement. Okay, so step number one, I hope you can tell me now, you can remember it. Write it in binary as 127. Okay, so initially we write it in binary as 127. So if you put the position value table, we have 1, we have 2, we have 4, we have 8, we have 16, we have 32, we have 64, we have 128, not 128, we have minus 128. Okay, and then if we have to fill this, so if you take 127, is closest to 64. 127 is closest to 64. So 127 minus 64, if you have to take it, you have 63 remaining. Okay, so you have 63. 63 is closest to 32. So you put a 1 over here. 63 minus 32, it will become 33, 31. Okay, it will become 31. Let me just double confirm. Of course, it will be 31. So 31 is closest to 16. So we put a 1 over here. Then 31 minus 16, it will be equal to 15. Okay, 31, if you take away 10, it will be 21. 21 take away 6, it will be 15. 15 is closest to 8, so we put a 1 over here. Okay, then 15 minus 8. 15 minus 8 is equal to 7. Okay, 7 is closest to 4. We put a 1 over here. 7 minus 4 is equal to 3. 3 is closest to 2. We put a 1 over here. 3 minus 2 is equal to 1. So we put a 1 over here. Okay, so remember the empty spaces, we put 0. Okay, so we only have one empty space, so we put a 0 over here. Okay, so now we move on to step number 2. Now we move on to step 2, yes, which is swap. Okay, so now we swap. So now what we have is 1 0 0 0 0 0 0 0 1 2 3 4 5 6 7 8. Okay, so now we do the swap. Then step number 3, add 1. Okay, so we just put a 1 over here and we add it. So 0 plus 1 is 1, and this will be 0 0 0 0 0 0 1. Okay, and then step number 4. Step 4, multiply value by position value. Okay, so very simple. I hope you have been able to grasp it. Okay, so let me put the values again and put the position value. So we have 1, we have 2, we have 4, we have 8, 16, 32, 64, minus 128. And if we write it 1 0 0 0 0 0 0 1, and if you were to multiply minus 128 plus 1, you would definitely get minus 127. Okay, so this is how minus 127 is represented in binary using 2's complement. Okay, right. So I hope you have grasped it, and it will be great if you could also try out the remaining 2 questions over here. Okay, minus 100 and minus 1, to give it a try and see how it comes. Okay, right. Let's take one quick example from over here. Let's convert this number. Convert the following negative binary number written in 2's complement format into a negative denary number. Okay, so they have told us that use 2's complement to convert this number into denary format or decimal format. Okay, so they have specifically told us this is a 2's complement number, or this is a negative number. Okay, so then immediately you know the way you write your position values is going to be different. Right at the end, you're going to have minus 128, not positive 128. Okay, right, let's get it down then. So we have 1 1 0 0 1 1 0 1. Okay, let's get it down. So the number that we had was 1 1 0 0 1 0 1 2 3 4 5 6 7 8. Yeah. So this we have to convert 2 decimal. 2's complement. Okay, so we're using 2's complement. Okay, so that's very easy. Okay, so what we do is we first put our position value. So we start with 1, then we have 2, then we have 4, then we have 8, 16, 32, 64. And then remember, we're using 2's complement. So we have minus 128. Okay, right. Let's put the values over here. So 1, 1, 0, 0, 1, 1, 0, 1. Okay, so now to convert, we have to multiply. The bottom and the top, we have to multiply. So we have minus 128 plus 64 plus 8 plus 4 plus 1. Okay, so if you were to do this, minus 128 plus 64, if you were to take it, it will become 120. It will become minus 80. I'm doing it mentally. It will become 124. 124, and then from that, if we take, it will become 84, minus 84, minus 84 plus 8. So we would have minus 80 minus 76, minus 76. Yeah, minus 76 plus 4 becomes 72, minus 72 plus 1 will become 71. So we would have minus 71 over here. Let me just reconfirm. So minus 128. 64 plus 8 plus 4 plus 1. Sorry, minus 51. My bad. Minus 51. My bad. I made a mistake, guys. It's minus 51. Okay, minus 51. This is the value that we would get. Okay, so if possible, do try the other two as well. Okay, so this is what we call 2's complement. It's a rather big part of data representation. Okay, next we will be moving on to something called character sets. Character sets is a very, very short part. Okay, not very long. So we have two types of character sets, the ASCII code and the Unicode. Okay, that is what we will be dealing with in the next part. Okay.